So we are now ready to dive into the first example to understand how the caches work. For this example, we are going to assume this particular toy memory system. So we'll assume that our main memory, it's a very small memory that has just 16 words. It's a word addressable memory architecture. Because we have 16 words, we need log to base 2 of 16, basically 4 bits for memory addresses. We'll assume that the CPU has only 4 registers, R0, R1, R2 and R3. We'll assume a very simple cache that has just 2 cache lines, and for simplicity we are assuming that all the instructions in our programs are only load word and store word instructions. Now note that these load word and store word instructions are different from the ANA load word and store word. These load word store word instructions, as you will see, they use direct addressing. Okay, so what does that mean? Here is the first program that we'll walk through, the first example. Now note that this first instruction, load word R11, right? What this means is, in register R1 we want to load the contents of memory address 1. So note that this 1 is the direct memory address. This is the complete address that we want to access. This is different from the ANA's load word. Similarly, the second load word R2 5. This means in register R2 we want to load the contents of memory address 5 and so forth. Okay, I hope this makes sense. So here is the animation. Note that this is the main memory. This has only 16 words going from 0 to address 15. This is the cache over here. It has only 2 cache lines. Each line has a valid bit, a tag field and a data field. Note that initially the cache is empty. Our CPU has only 4 registers, R0, R1, R2, R3, and this is the sequence of instructions that we want to execute. Okay, so let's begin. The first instruction is load word R11. So recall that in register R1 we want to load the contents of memory address 1. So because we have a cache in the system, we will first go through all the tags in the cache and see whether this address 1 is present in any of the tags. Now unfortunately the cache is right now empty, so address 1 is nowhere to be found, so this is going to be a cache miss. Okay, now in response to this miss, we'll bring this address and the data from the main memory into the cache. So that is what is shown over here. We'll basically, what we'll do is we'll set, let's use the top line which is empty to bring the new data. So we have set the valid bit to 1. Next we'll set the tag field to the memory address 1 that we want to bring in, and then we'll bring in the data 110 into the data field, and from here we'll store the data into this register R1, right? So from the cache the data would be returned to register R1. Okay, the next instruction is load word R2 5. So we want to bring this data from address 5 into register R2. So again we'll first check the cache. Is this address 5 present in the cache? Unfortunately right now there is only one address, which is 1, so 5 is going to miss. Again in response to this miss, we'll bring this memory address and the data item into the cache. So let's use the second available cache line to do that. So we'll first set the valid bit to 1. Then we, in the tag field, we'll store the address 5, and then we'll get the data item 150 into the data field. And then from here, this 150 would be returned to register R2. So as shown here. Now note that this second line was just now populated. So the top line, this will become the LRU line. So we should start. Now note that both the lines are full now. So it is important to start tracking the LRU information in case the eviction is needed. Next we have load word R31. So again we'll check the cache if this tag 1 is present here. Unfortunately you see 1 is present in the top line. So this is going to be a hit. No need to access the main memory. We can simply get the data 110 from the cache and return it to the register R3. So that is what is shown here on the next few slides. So this is a hit. In response to this hit, we just got the data 110 from the cache to the register R3. Now note that the top line was just now accessed. So the bottom line would now become the LRU line. Okay. Next we have load word R37. So again, yes, that's right. You see address 7 is not present in the tag array, right? There is only 2 addresses, 1 and 5. So this is going to be a miss. Again, in response to this miss, we'll bring in this address 7 and the content from the memory into the cache. But note that the cache is full. So we need to evict something, right? So we'll evict this LRU line, the second line. So let's do that. This is a miss. We'll evict the second line. So basically we are now overwriting the tag field with the new address, which is 7, and then we'll overwrite this data field with the new data, and then from here we'll return the data to register R3. Okay, and next, note that we have just now populated the second line, so the top line should become the LRU line now. Okay, finally we have load word R27. Now is this address 7 present in the cache? Yes. So we just now brought it in, so this is again going to be a hit. So we no need to go to the main memory, we can simply get the data from the cache and return it to register R2 as shown here. Okay, so this is how the caches work.